Good morning, everyone, and welcome to our next AIM to Learn. My name is Matt Minner with Catalyst Connection, and today we have Delta Bravo here with Rick Oppedisano. So good morning, Rick. Thanks for joining us.
Good morning, Matt. I appreciate the opportunity to tell our story.
Yes, absolutely. We're excited to hear it. And today we're focused around advanced analytics and AI. Is it reality versus hype? So Rick's going to sort that out for us, and we look forward to hearing about that, and also with a pretty interesting and applicable case study for us. So just before I hand it over to Rick, I'm going to just sort through a little bit of an overview of AIM Hire, as this AIM to Learn session is brought to you by the AIM Hire Consortium, which is a Department of Defense funded program geared to strengthen and expand the defense supply chain in Southwest Pennsylvania and West Virginia. We do have a focus on the adoption of advanced manufacturing technologies, and we are particularly excited to have Rick on this morning to talk about the application of AI. We have a number of benefits to supply chain members, including mini grants and other connections. As you can see here, we have a wide range of economic and workforce development partners, technology institutes, and many universities that you'll recognize from across the region. We also have our supplier capabilities database, which is free to join. So if you haven't had a chance to do so, our manufacturers in the region, we're wanting to have this database so we can highlight it to defense partners and other prime contractors, and just have a way to promote the rich density of defense manufacturers in the Pittsburgh region and in West Virginia. We've had a very wide impact with all of our partners, as we have 14 partners across the region. You see millions in investments driven through our projects and retained sales, and that jobs created numbers. Really, that's one of our prime focuses around training and just helping retain and create new jobs. And lastly, we'll touch on, we do have this AIM to Learn session twice a month. Our next one will be on February 23rd, where we'll have Hammer Industries joining us to talk about their novel cold spray technology as a slightly different. We may not be as familiar with that technology as it relates to additive manufacturing. So look forward to that. And of course, if you miss that one or any others that you'd like to revisit, go to our AIM to Learn site. That's on the AIM Hire Consortium website. You're able to watch them on demand. So with that, let me make you the presenter, Rick, and we'll hand it over to you.
Excellent. Thanks, Matt. I appreciate that. Let me get my presentation up here, and if you could please let me know whether or not.
Sorry, Rick, just wanted to remind everyone, if you do have any questions, feel free to put it in the chat window or the questions panel that you'll see on the GoToWebinar dropdown. I'll be watching that and can chime in with questions during, and then we'll take questions at the end as well. So with that, I'll let you take it, Rick.
Wonderful. Are you guys able to see my screen?
Yes, it's coming through great.
All right, perfect. Well, hello, my name is Rick Oppedisano. I am the CEO and founder of Delta Bravo Artificial Intelligence. And so what we're going to discuss today is really kind of, our experience in this field. We're going to go talk a little bit about, that context, and then get into what we're seeing in the market. What are the trends? What is working and what isn't? Why isn't it working? What does it look like when it does, right? And then ultimately share with you guys some lessons learned that we've put together over the 7 years or so that we've been working in this field. So can everybody see the next screen here?
Yes, coming through great.
All right, excellent. So a little background on Delta Bravo. So we work with manufacturers, that is our sole focus. And when you think about data in a manufacturing operation, it's coming from all over the place. It's coming from the factory floor, places like this. It's coming from quality operations, financial and business analysis, the warehouse, supply chain, so there's logistics. So there's all sorts of different types of inputs that create data in a manufacturing operation. And so you think about what Delta Bravo does is that we take all that data from all these different parts of the operation, we bring it together and turn it into predictive models that can help our manufacturers improve throughput, improve quality, reduce unplanned downtime, reduce waste. Think about even all the way into sustainability, things of that nature. So what we do is take all this data from these disparate silos and put them together. And so the value proposition of our business is ultimately creating insights that help improve operational margins. What are we not seeing here from a production standpoint? Is there a way that we can improve efficiency? Is there a way that we can reduce risk around workforce readiness and attrition? We do this by giving people better tools to automate decision making, automate the collection and analysis of millions of data points to give them an understanding of the best decisions to make in the context that they're in. And then ultimately, we help our manufacturers create competitive advantage by scaling these capabilities. So when you take a financial impact plus a workforce impact, and you're able to scale that across multiple products, lines, and plants, that's a big deal. Differentiators for our business is that, like I said earlier, this is all we do. You're not going to get a B team because we don't have one. All we do is manufacturing. Our technology is a centralized data platform that allows us to do a couple of really interesting things. One of them is that we can integrate data from pretty much any kind of source that creates it, which is a very flexible approach. We work with what the manufacturer has. And then secondly, our technology platform allows us to integrate our solutions into your processes in the best way possible. The idea here is to make sure you minimize disruption. So we make it real in a number of different ways. We fit it into existing processes in a way where you get a capability and not a distraction. And what we found from a process standpoint, with working with some of the big names you see down here, is that this is not the type of thing that you want to boil the ocean with. This is the type of things that you want to take it in bite-sized chunks that make sense, that are quick to scale and cost-effective to scale. And so that's really the little background on us. And so when we think about the whole advanced analytics and AI thing, what does it look like when it works? And this is, stories like this are the kind that, get people really excited about this opportunity. And so this is a story about one of our customers called Elkem Silicones. They make about 400 different silicone products, and a little over 40 of them could be considered problem children, right? Where we've got a first time right problem where we've got, an average of 4 passes, per product production round, right? And so when you think about that, obviously, that they're spending more money on raw materials, that it creates kind of a lumpy supply chain, supplier order relationship, complicates inventory potentially. So what we did is we ended up taking a lot of their data, put it all together, and we created a predictive model that tells them if and when one of these mixes is going to come out of spec, and it tells them where in the process to add what raw materials to bring that mix back into spec and avoid that negative quality outcome. And so as you can see by some of the bullet points there on the left, we were able to help them reduce these passes from 4 passes to 1 on 40 products. And so when you think about that savings, it's pretty palpable, right? See some of the numbers down there. So it's stories like this that get people excited. They say, oh, geez, it can work. And then people get even more excited when they hear stories like this. What happens when it scales? So, again, over the years, we've seen, some pretty cool applications in the plant floor where we start with something like advanced analytics, the idea of bringing, really pumping up your OEE, moving OEE from a simple KPI to an understanding of what influences that KPI. The idea of saying, hey, instead of saying, well, we have X number of defects, what we now see is that, hey, when we raise metric A in the first step of the process, that influences metric C in the third step of the process, and that is the contributor to our negative quality outcome. So the idea of turning OEE from a single variate analysis into a multivariate analysis, very powerful and a very good first step. And from there, you can get into things like predictive maintenance, hearing the irregular heartbeat before the heart attack of unplanned downtime or performance degradation. Predictive quality, like we just saw with Elkem, the idea of being able to predict a negative quality outcome, understand what's going to cause it, and let the operator know what they can do in order to avoid that negative quality outcome and turn it into a positive one. I would say the biggest growth area in our business in the last 6 to 8 months has been around concepts related to sustainability. So this is the idea of everything ranging from better facility energy management, the idea of integrating weather data and HVAC data and staffing data, shift data, to understand how and where people use certain aspects of the building so that you can optimize temperature set points and things like that to reduce your energy footprint and save money. Other areas include optimization of water, wastewater, chemical usage, things of that nature. The idea of moving from virgin raws to recycled raws and how that influences quality. So we're seeing a lot of growth in that area. And then lastly, supply chain, the idea of understanding what our demand forecast is going to look like and how that's going to influence production. Is there a better way for us to optimize our plant floor scheduling in order to minimize changeover related downtime? So these are the areas that we see that, when we start and then when we scale, they make a huge impact on the business. And so ultimately, the next question is always, well, geez, it sounds great. Why isn't everybody doing this? And so let's talk a little bit about, kind of what we're seeing when this goes wrong. So the first big challenge that people have is the reality that the data that's being generated in a manufacturing operation is extremely complex and sometimes doesn't have the level of quality that people like us are going to want, right? And so what I mean by this is that when you think about a PLC that could be collecting data at 0.5 hertz or 5 hertz or 10 hertz, that data is coming in, maybe every metric's coming in maybe 3 times a second or once a minute. When you have to sync all of that, that's pretty complex. It's complex to do it in a way where the data remains accurate and the quality remains high. So that's one big challenge that people are greeted with almost immediately. And they say, well, shoot, maybe we need to find some people that know how to do this. Well, it turns out that the competition for these types of resources is a lot greater than manufacturers saw or thought that it would be. All of a sudden, you're not just competing with another local manufacturer. You're competing with Google, Facebook, Amazon, BMW, Tesla, us, right? So it's really hard to find and keep skilled people in this area. And what's interesting is that, a lot of folks tend to go to universities, things like that. And so what'll happen is, they'll get somebody from a university, but that person will have to really, take them a long time to really understand the business and how to use the data in a way that impacts the business, because they don't really necessarily know manufacturing, and it takes a while to learn it. And so once you find these people, the next big hurdle is the availability of subject matter experts on the business side to help them create the outcomes that you need. So, with everybody's resources being stretched in this market, leadership and subject matter experts, they are, they're running double shifts, right? I mean, these people are really, really busy. So the availability of those internal resources to guide the efforts, that's also been a challenge. And then ultimately, if you can even put all of that together, congratulations on your fancy math, your machine learning model. How are you going to integrate it into the business in a way that does not disrupt the way that we're doing things today? Right? So these are the big challenges that we see out there that really inhibit these efforts, and they contribute to numbers like this. So big analysts like Gartner and Emerge, people in our space, they estimate that about 80% of the first-time efforts in this area fail. And so when you think to yourself, you say, okay, well, I understand the benefits of this, but geez, an 80% failure rate, who wants to take that deal? Well, as it turns out, a lot of folks are. Because when you step back and you think about the market conditions influencing these types of efforts, take a look at what's happening. You're seeing a compounded annual growth rate of 47.9% between 2022 and 2027. Staggering, all right? It's a huge number. And so when you see numbers like that, what you realize is that the pain is intense enough where you have to do this in order to survive. So whether you feel that this is a hype thing or a reality thing, it's happening. And your competitors look at this as something that's core to their survival. And so this is really the movement in the market. And so what I want to do is I want to transition from just kind of this general understanding of why things are difficult. And I want to talk a little bit about the context that we have on these efforts. And I want to share with you guys some lessons learned. So we have really kept track of all of our projects since 2017, by 93 of them, all right? And if you take a look at some of these results, not all of them have been great. If we take a look at the 3 on the left side, we've had negative ROI in a couple of projects, neutral ROI in a couple of projects after 2 years, very slow ROI in a couple of projects after 2 years. And so when you take a look at that part of the chart here, we affectionately refer to that as our pilot hell period. This is a time where we struggled with all of those things that that I saw on the previous slide, getting the right people, getting resources from our customers, really understanding and picking the right use cases that were appropriate for these types of efforts that would drive the returns. Now, what's interesting is if you take a look at the set of 3 over here on this side, now this tells an entirely different story. This is showing very strong ROI within 6 months or less, 6 to 12 months, 12 to 24 months. And this is really where our business turned the corner, where we achieved a level of process maturity and product maturity that really drove strong results for our customers. And so what I want to focus on is the process maturity. And so this is something where, the audience here and that is listening to this is going to be something that really helps you mature quickly and avoid a lot of the mistakes that plagued people like us for the better part of 2.5 years. Okay. So the first thing that I want to talk about is that, like I said, there's a process and a framework here that works. And it all starts with recognizing that this is a cross-functional effort. This is not just something that is going to require input from somebody in maintenance or just somebody in quality. This is something that, when it's done correctly, unites data sets and processes from multiple lines of the business. And so therefore, you're going to have some level of consensus. And that consensus has got to start at the top with what we call a North Star principle. So if you see those little boxes, those little red boxes, these are actually taken from one of our big aerospace customers. They're a leading aerospace manufacturer. And and if you take a look at them, they look pretty simple. But it took us about 2 weeks to get everybody to agree on these things. Win faster, win future market share through faster production, higher quality. Using technology and investments to turn one person into three, maximizing the lifespan and performance value of capital equipment, improving communication and data flow. So these are all things that we recommend folks start with. Start with this North Star statement. There could be 2, 3, 5, 10 of these, whatever. We tend to see 5 as being kind of the sweet spot. So once you have those principles defined, then that'll influence what you consider to be a proper use case. And so once people start looking at use cases, they're going to start talking about things like predictive maintenance or predictive quality, scrap reduction, things like this, demand forecasting. And so when those suggestions for use cases come in, we recommend that you frame those use cases through what we call kind of our value trinity. All right. And so the first area is pretty obvious. Is there a financial return on investment for solving this problem? What is that financial return on investment? How do we quantify it? So the good news is that in a manufacturing environment, things like improving uptime or improved utilization, minimizing changeover related downtime, these are things that are easily financially measured. And so we start there. Now, the one thing you want to do is you want to make sure you don't just get hung up on that, because this being cross-functional, it requires a lot of people to play together in order to achieve that ROI, okay? So sometimes certain parts of the business take longer than others to kind of play along and get involved in the process. So you don't necessarily want to hang yourself on a noose of short-term return on investment financially. You also want to look at things like what we call a capability ROI. And this is the idea of reducing workforce attrition risk, improving workforce readiness and resilience, the idea of automating complex analysis to give people better tools to make better decisions faster, to reduce training time, to make them more valuable to the business, right? So when we think about competitive advantage, competitive advantage, regardless of your business, is always going to be rooted in doing things faster at a higher level of quality at a lower cost, having people that can do this quickly, minimizing the impact of losing those people and maximizing the ability to make those people valuable quickly, all right? So these are the things that when you think about these use cases, number one, do we have a financial return that we can measure and track? Number two, does this make our employees' jobs easier? Does this allow us to make them more valuable to the business faster? And then number three, can we scale this across multiple products, lines, and plants to maximize the return on investment and achieve a competitive advantage? So from there, if your use case meets those criteria, what we do then is we say, okay, well, maybe we got 3 or 4 of these use cases that meet this criteria. So what we do is we put them through what we call the Delta Bravo Bullseye framework. And this is a framework that's really built around the concept of building consensus across multiple lines of business, understanding how and where to prioritize the time and resources that are required from the manufacturer to execute this, minimizing the risk, right? We don't want project failure, and then limiting any sort of rework, right, or redundancy. In the same way, you don't want that in your processes, you don't want that in your projects. And so the Bullseye framework really focuses on 4 concepts. Number one is simple. How hard is this to do? Do we have the data available? Do people buy into this? And then that kind of bleeds into our support metric. Does everybody see the value in this? Is the resource from quality going to contribute some time? Is the resource from maintenance going to contribute some time? Do they believe in this? Are they going to prioritize it? Where does this fit? We call this sample. So if we come up with a solution, how and where in the process does this fit? How and where can we pilot this? Where can we insert this, and how does that have to be done? Does that have to be done by integrating into an existing application or system? Do we need a new interface? How does the user consume that? And then lastly, how can we scale it? So we want to make sure that we don't do one thing that's just effective on one line with one concept. How do we scale this out to maximize that return? And so when you think about the concept of this framework, and we have 4, 5, 6, 7, 8 use cases, this helps us really understand it, put them in the right order, prioritize them. And sometimes the results aren't what you think. I mean, this is an example from another one of our customers where all the talk was about anomaly detection for predictive maintenance. But as we got into another use case that was more associated with scheduling optimization, that turned out to have a higher level of priority and a higher impact on the business than the predictive maintenance application. So this is, again, just a way to have a very clear mindset, a very clear look and a view on what matters and how to go about attacking that and in what order. So what does it look like when it's right? You know, this is a good example of the bullseye framework and some of these concepts in action. So we've been working with Nucor Steel for a few years, and one of the big applications that we have there is a predictive quality application. So they make about 1,100 different SKUs in this particular plant that we're working with. And so, you know, they were experiencing some level of quality problems, right? Because they were moving from, you know, kind of conventional specs into things for the Department of Defense, where the level of spec and quality was a lot higher. And so they wanted a way to quickly train people to be able to execute on these new specs without having to go through a lot of the headaches and you know, quality issues that usually come with that type of an idea. And so what we did is we actually took all their data and we created a model that in real time predicts grade changes, it predicts when all these different elements are going to come into tolerance, and it tells the operator exactly where to make a decision that maximizes the quality of the first SKU and then minimizes the steel scrap moving into the second SKU. So really interesting use case. You can see here on the interface, this actually sits on a screen in their control room. And they take the recommendation from the AI and it says, okay, well, you know, if we're going to come into tolerance at 281 inches, they punch 281 into the HMI, into their level 2 system, and then that system makes the cut. All right, and so you're seeing that we're maximizing the quality and tensile strength of this SKU and minimizing the steel scrap moving into this one. So pretty interesting, pretty interesting use case. Great, great outcome. If you take a look at that measurable ROI, going back to that triangle that we looked at before, the value trinity. You know, we're saving over $1 million a year per plant. We've reduced their energy footprint by about 5% because when you reduce rework, you reduce the use of electricity and water, which in a steel mill is pretty substantial. This particular mill comprises about 3% of the total energy use in the state of South Carolina. So reducing that number is significant in a number of ways. Reducing the steel scrap by 17%. Now that's a metric that everybody should be able to understand and get with. The capability ROI, the idea of reducing employee training time, giving these folks better tools to work with. This is something that, by all admissions, took 6 months to a year to learn. Now it takes a week or two. So we've reduced that employee training time, we've reduced that risk of attrition, we've made people more valuable to the business faster, and we can scale it. This is not just a single melt shop operation. We can scale this across 20 different melt shops company-wide. So this is what it looks like, when life is good, when you go through things the right way. So when you think about what it takes to get this party started, number one, what we've found is that this is the type of thing that if it starts in R&D, and that's really kind of the prime owner of the concept, it's not really going to work out. It's going to stall because other parts of the company are not going to prioritize their time. So the number one thing that we see when we're successful with customers in these types of endeavors is that leadership at the highest levels, they're bought in. They've told their management teams, prioritize this effort because we need to get in front of this. We need this to compete. Okay, and so that's number one. Number two is an understanding of your systems. If you have executive buy-in, maybe there's some level of pressure coming from the top down saying, hey, we have to do this. You can't just throw anything at it. Your data doesn't have to be perfect. There's ways to do this, and there's roadmaps that you can get on that over time can continuously create higher levels of value for the data. I mean, there's plenty of ways to go about this. Data doesn't have to be perfect to get started, trust me, but it does need to exist. So if you want to do a predictive quality thing and people are just writing stuff down on a piece of paper and throwing them away after a month or two, that's not going to cut it. All right. So You have to know your systems. You have to start with something that's a game that's winnable, right? Then lastly, we recommend finding the right partner. Trying to do this in-house is not reality, all right? Not reality for most folks. It might be a reality for BMW, Tesla, people like that, but it's not going to be a reality for the mid-market. It's not going to be a reality for the small market. So we'd recommend finding a good partner, someone that can help you create fast results. You do not want to get into a situation where you've got to wait 6 months to get something back to the business. You want to be able to show something quickly, and something that really ties to financial impact. And that's super important, right? Because nobody wants to spend $100 to make 50. So those are the things that, in terms of just getting started, I would really focus on, some good attention placed on those concepts. And so ultimately, when you ask that final question, is it reality or is it hype? Based on our experience, this is absolutely reality, and the market trends seem to back that up. So I'm happy to take any questions. My contact information's down there at the bottom. Feel free to call us. We love to talk to people, whether that's in a business context or even just in an informational one. We try to be thought leaders in this field and a great resource for the industry, because this is what we're passionate about. And Matt, thanks again for the opportunity.
Yeah, absolutely. No, great presentation, Rick. Thanks so much for going through that, and in particular sharing the case study that you had. One thing that was interesting, you talked about how data doesn't have to be perfect, but it does have to exist. And when we're talking about data, lots of companies, they got their PLCs, they got machine tools, they got all sorts of stuff generating data. But whether you're talking quality information or, like, say, failure, if you're going more the predictive maintenance side, what are the key aspect? Like, is like good versus bad? Like, just to keep it a high level, good data versus bad. This was a good part, this was a bad part, or this is data associated with a failure. How important is it to have those elements versus just, well, I have all this data streams coming in. Can you make sense of it?
Yep. So good data is automated stuff that's created by a machine, something that doesn't rely on subjectivity. So PLC data is good data. Bad data is data that is affected by people and that has minimal fences around it. So think about an Excel spreadsheet that you have an entry, some sort of a form entry on that Excel spreadsheet. And maybe it's supposed to be a number, maybe it's a tolerance range. But if you don't have that field locked down and people can enter letters in there, or they can enter numbers that are beyond the acceptable tolerance ranges, right? That's a bad data situation. So number one, automated is always better. But if it's got to be manual, you have to have some level of validation around that data, some fences around how and what people can enter. So that's the first part of it. The second part of it is the amount of data. Okay, so what we find is that there's plenty of people collecting data on PLCs, but not enough of them are networking those machines and saving that data. So we, in our business, we don't need necessarily a ton of data. We just need enough examples of good behavior and bad behavior. So a good behavior is a positive outcome, a positive production outcome that met specs, that met cycle times, that met the OEEs and the KPIs that we traced, right? We want plenty of samples of these. What does good behavior look like? But we also want some bad behavior. And we want to see what that looks like, and so that we can start to detect anomalies across that process that could contribute to that negative outcome. So I would say, number one, make sure you do your best to standardize and limit the amount of variation in the data that you collect. And then secondly, make sure that you're networking your machines, all the different parts of the process. Bring that data in and just save it someplace. Make sense?
Yeah, absolutely. No, that sounds very good and makes a lot of sense. And just one other question we have. You talked about, kind of forget what you call kind of the mission statements, or those kind of 5 to 10 statements
the
that
North
you
Star.
created. How does that, because they were related, but maybe sometimes different. How do you kind of mesh that with the idea of, starting small and simple and, doing one and then iterating from there? How does that kind of come together?
Yeah, so it's just the guide. It's like it's a guiding principle, right? It's like when you're married and you get in an argument with your wife. What gets you out of the argument is the fact that, hey, in the end, look, we're both stuck here and we both want the same thing. We want a healthy family environment, and we want these kids to grow up with with a good mindset, right? And so that's really what the purpose of the North Star statement is to help people maintain and reinforce the focus at a high level of where we're going with this. So if you look at those North Star statements, right? What they won't support is a single cowboy going over here and doing something with a different vendor or doing something on his own with his own people and resources that doesn't apply to something else, right? What it does is it makes sure it ensures that everybody stays on the same page, and you just have that litmus test when the inevitable conflict happens. Does that make sense?
Yep. No, absolutely. Absolutely. Okay. I think we have time for just one more question here. Some of the companies that you've listed across there are on the larger side, but you said, this really does apply. I mean, have you had some examples or some engagements with those in that medium and small sector where you've had some success with those, and maybe any, takeaways from those types?
Yeah, plenty. So I think that the need is more acute in the mid-market because they're not going to be able to compete for the types of people. These people cost real money, right? So they're not going to be able to compete for the type of people from a financial standpoint and from a brand standpoint that the bigger players are, right? If you got a choice to go to mid-level supplier A versus BMW when you're 24 years old, 26 years old, 30 years old, you're going to go to BMW, right? So we've worked with, I would say probably a good 40–50% of our customers are that kind of mid-market. And so there's a lot more pressure on them that's coming down from their OEMs, the people that they supply. They're saying, hey, get this right, make this part of what you do. They're getting pressure around these types of things. They're getting pressure around sustainability. So ultimately, those folks need this, and it's more impactful on their business than it even can be at the OEM level. And so that's where, yeah, I think this is a huge deal. And again, we take a look at where it affects those mid-market guys. Number one, they're chronically short-staffed. Number two, like you said, they're not going to attract these people. Number three, they're going to need to go back to their OEMs to be able to report that they're doing these types of things. Sometimes the OEMs, at least in our experience, we've worked with a couple of them that want to integrate supplier quality data, with their own data for deeper analysis. And if these mid-market guys don't have the ability to produce and share that data in a reliable, repeatable way, then that's an area where they could be usurped by a competitor, right? So it's a huge deal for mid-level folks.
Okay, well, thank you again, Rick. This was a great conversation, and a reminder for everyone on this will be recorded and up on our AIM Hire website on the AIM2Learn page. So thanks again, Rick and Delta Bravo. Appreciate your time.
Appreciate the opportunity. Thank you very much.
All right, everyone have a great day and a great rest of your week.